Hello friends, this is Yogesh and today again we are here to discuss a very important topic of kinematics, that is speed and velocity. Before proceeding to these topics straight away, let me discuss the few points that we had a discussion earlier in this topic. We had a discussion on motion, which means the change in position with respect to time and with respect to reference point. We had a discussion on the significance of reference point. We had a discussion that motion and rest are the relative terms because they depends on the respective positions of object as well as observer. We had a discussion on distance and displacement. Distance is the total length of the path followed by the body. It is a scalar quantity with SI unit meter. Displacement is the shortest route of the path between initial and final points. Its SI unit is meter and displacement is a vector quantity, and we have practically related with the different examples that why distance is called scalar quantity and displacement is called a vector quantity. Today we are going to discuss about the speed and velocity, and that too very specific average speed and average velocity, and if the time permits we will discuss the instantaneous speed and instantaneous velocity also. So let us start with the topic today. Today's topic is the speed and velocity. I have written the formula this side. The speed is defined as the total distance traveled by a body per unit time. That is, speed is equals to total distance upon total time. Speed is a scalar quantity and its SI unit is meter per second. It is a ratio of distance and time. So the SI unit of speed will be meter per second. If we talk about velocity, velocity is dependent on displacement. The velocity is defined as the total displacement of a body per unit time. Its SI unit is again meter per second because it is the ratio of displacement and time, and velocity is a vector quantity. To remember this, whether speed is a scalar quantity or a vector quantity, or velocity is a scalar quantity or a vector quantity, generally the students get confused while writing in the examination or while remembering this. So we have a very simple shortcut. S stands for speed, S stands for scalar. This S stands for speed and S stands for scalar. V stands for velocity and V stands for vector. So in this way you can remember velocity is a vector quantity and speed is a scalar quantity. I have different examples with numerical values to discuss speed and velocity in different cases. There are certain differences that we had a discussion in my previous class about distance and displacement. हमने distance और displacement पे अलग-अलग topics पे उसके difference पे भी हमने बात की थी. Today also we will have a discussion on the difference between speed and velocity, and to clarify that I have different examples, 3-4 cases I have taken, and we'll discuss one by one for different cases, so it will be little more clear to you. Okay, so let us discuss the first case. In first case, the body initially is at point A and it reaches to point B. Although I have marked point C also, but there is nothing to do with point C in case 1. We just need to focus on point A, initial point, point B, final point. Suppose we have started at T1 is equals to 0, simply I have written T1. You may write here T1 is equals to 0 and T2 is equals to T. So for case number 1, when we are traveling from point A to B, we have to find out for this particular case, when we are moving from point A to B, what will be the speed and what will be the velocity. I have not taken numerical values in the first case, we will take in the second and third and fourth cases. Okay, so for point A to B, if you see here, point is written x1 and here point is written x2. So what will be the separation between point A and point B? x2 minus x1. If I write here 0 and if I write here 5, so the total length of the line will be 5 minus 0. So similarly we are writing x2 minus x1 will be the total distance. Now separation, that is the difference between time, will be simply T2 minus T1. So this will be T2 minus T1. If you take T1 as a 0 and T2 as a T, you will write here t minus 0, which will be simply t. Okay, just to understand, you may write t2 minus t1, or if you are taking the initial time to be 0, you may write t minus 0 also. So the speed becomes x2 minus x1 upon t2 minus t1. Again, total distance upon total time. To indicate the difference of the same quantity, generally delta sign is used. यहाँ पे एक मैंने ट्राइंगल बनाया हुआ है. This triangle sign is called delta, or you may simply say it as del. So this is del x upon del t. Difference of x, x2 minus x1, so I am writing it del x. Difference of time, so I am writing it del t. Suppose if it is z2 minus z1, so what you will write? Del z. u2 minus u1, what you will write? Del u. z2 minus z1, del z. y2 minus y1, del y. Okay, so similarly for velocity, if we talk about, this is the speed, total distance upon total time. Now in case 1, we are moving only in one direction. This is a unidirectional motion. We are starting from A and ending at point B. So if we are starting from point A and ending at point B, velocity will be equals to final point. We have to calculate the displacement for velocity. So final point is x2 and initial point is x1. So the velocity will be displacement x2 minus x1 upon t2 minus t1, that is total time. Again, this is del x upon del t. Since it is a unidirectional motion, and my previous lecture we had a discussion that in unidirectional motion the magnitude of distance will be same as the magnitude of displacement. So in this case, if you calculate, the speed and velocity magnitude will be same, although here x indicates distance and here x indicates displacement. In case of speed, x indicates distance, and in case of velocity, x indicates displacement. But it is a unidirectional motion, so if you calculate the numerical values also by keeping the different values for x1 and x2, you will get same magnitude for speed and velocity. Suppose if I take here x1 to be 0 or x2 to be 6. So here also it is x2 minus x1, so 6 minus 0. Here also it will be 6 minus 0. Initial time you may take 0, and if I take it as 2 seconds, so again it will be 2 minus 0 for both speed and velocity. In second case, I will take a backward motion. Okay, so in second case, if you see here, I have written 0. This is point A, initial point. In second case, the path is from A to B and from B to C. That means we are traveling from A to B, and again we are coming back up to point C. So for this complete path, you have to calculate speed and velocity. Suppose traveling from point A to B, the time taken is 4 seconds. When you are traveling from point A to B, time taken is 4 seconds. When you are coming back from B to C, टाइम टेकन है सपोज 6 सेकेंड. ब्रेकर वगैरह बीच में आ गया होगा, है ना, बहुत ज़्यादा भीड़ हो गई होगी वापसी में, तो हमको टाइम ज़्यादा लग गया यहाँ पे, है ना. ठीक है, दिस इज जस्ट एन एग्जांपल. सो T1 यहाँ पे ऐसा मत सोचना कि जाने में 4 सेकेंड लगा और आधे तक आने में 6 सेकेंड लग रहा है, ऐसा क्यों हो रहा है. दिस इज नॉट द केस, इट डिपेंड्स ऑन द सिचुएशंस, है ना. आई मे टेक एनीथिंग हियर, देयर इज नो इशू. यहाँ पे ट्रैफिक का भी केस ले सकते हैं, कुछ भी केस ले सकते हैं. दिस इज जस्ट एन एग्जांपल. सो डोंट बी सो फोकस्ड ऑन दिस लेंथ की बड़ी लेंथ ट्रैवल करने में 4 सेकंड लग गया, आधे में ट्रैवल कर रहे हैं बी टू सी तो 6 सेकंड लग रहे हैं, ऐसा कैसे हो गया. ठीक है, इट डजंट मैटर फॉर मी हियर, द कॉन्सेप्ट मैटर्स फॉर मी. ओके, सो A to B, if we are traveling, we are taking 4 seconds, and when we are coming back from B to C, we are taking 6 seconds. So total time, if you see, from A to B and from B to C, this is the final point. Ultimately, C is the final point as per the given path, A to B and B to C. So A to B we have taken 4 seconds, and B to C it is 6 seconds. Here I have marked 0, 3 and 6. That means from 0 to B, that is from A to B it is 6, and from B to C this is 3. Okay, so if we talk about total distance for path A to B to C, so what will be the total distance? 0 to 6, 6, and 6 to 3, that is 3. The total distance becomes 9. This is 6 plus 3, 9. Total time 4 plus 6, 10. Yeah, get total time. 9 upon 10, 0.9 meter per second. 0.9 meter per second is the speed. But when we talk about velocity, velocity depends on the displacement. So here the final point is C and initial point is A. So what will be the displacement? C to A, that is C minus A or 3 minus 0. और अगर definition के हिसाब से भी जाएंगे, so it will theoretically it will be the shortest route. So what is the shortest route between A and C? CA. So 3 minus 0, that is 3 upon total time is again 10 for the complete journey. So 3 upon 10 is 0.3 meter per second. So if you see here, the value of speed, that is the magnitude of speed, is greater than the magnitude of velocity, similar to distance and displacement. Okay, so this is the case when we have started with the backward motion. I have one more case here. Suppose we are traveling from north to south 4 meter I have taken here, and again we are turning towards east and we are traveling 2 meters. Okay, so initial point is A, final point is C. We traveled from A to B and we turned from B to C. This is 4 meter, this is 2 meter. So distance, I think there is no doubt in distance. The distance traveled is 4, 2, 4, 2, 6 meter. So this is 6 meter. Okay, this is 6 meter. If we talk about displacement, what is the initial point? A. What is the final point? C. What is the shortest route between A and C? Join with a straight line. You will get hypotenuse because this is the right angle triangle. So hypotenuse will be equals to, here straight away you can write here, this is 4 square plus 2 square, under root 4 square plus 2 square will be the displacement. So displacement will be equals to AC, under root 4 square plus 2 square, that is under root 16 plus 4, under root 20, that is under root 5 into 4, and you can write 2 root 5. Root 5 is around 2.23. So displacement becomes 2 root 5 meters, whereas distance becomes 6 meters. Time I have taken, suppose you are traveling from A to B, you are taking 5 seconds, and from B to C you are traveling in 15 seconds. बहुत ज़्यादा breakers होंगे, ऐसा मान लेते हैं. So from B to C we are taking more time. You may write, for example, you may take less time also. This is just an example. So velocity is equals to 2 root 5 upon 20, because 2 root 5 is the displacement, upon 20, that is root 5 by 10. Root 5 is, I told you, 2.23. So ultimately it will not be 0.023, it will be 0.223 meter per second will be the velocity. Velocity is the displacement upon displacement upon time. If we talk about speed, speed is 6 upon 20, because total distance is 6 meter and time taken is 20, that is 5 plus 15 is equals to 0.3 meter per second. So again, if you see here, speed is 0.3 meter per second, whereas velocity is 0.223 meter per second. Okay, so from these three cases, this is very much clear that speed can be equals to velocity in magnitude for a unidirectional motion, or speed will always be greater than the magnitude of velocity, similar to the case of distance and displacement. Now if I take case number 4, I am going to modify this case only. Let me take case number 4 here also. Suppose if I take case number 4, and if in case number 4 if I take, the body is again coming back to point A. The body is again coming back to point A. Okay, this was the case. This is 4 meter. Okay, this I have taken 2 meter. Don't be so artistic. Okay, just focus on the magnitudes. And again the body is coming back to point A. This is case number 4, and body is traveling from A to B to C and coming back to A. This we have already calculated 2.23, sorry, not 2.23, it is 2 root 5. It is 2 root 5. So 2 root 5 is 2.23 I have taken, so this will becomes 4.46 meter. 4.46 meter. I am talking about only about the concept. Now for this particular case, if we talk about speed, A to B 4 meter, B to C 2 meter, and C to A 4.46 meter. So this total distance becomes 4 plus 2 plus 4.46, that is 10.46. And if time I take traveling from C to A, from A to B, the time I have taken 5 seconds. For B to C, time I have taken 15 seconds. And for C to A, if I take 10 seconds. So total time becomes 30 seconds. Okay, so the speed will be equals to total distance upon total time. If you see, it is 30 seconds, almost 1/3. You can say this will be the value of speed. Okay, value of speed. But when we talk about velocity, this case I have taken specifically for velocity. So if we talk about velocity, what will be the velocity? What will be the velocity? What will be the velocity? Velocity is equals to displacement upon time. Now the body has reaches to point A again. That means initial and final points are same. If the initial and final points are same, displacement will be 0. So 0 upon 30 is equals to 0 meter per second. That means in this case the velocity is 0 meter per second and the speed is 10.46 upon 30, almost you can say 1/3, that is 1/3 meter per second. You may calculate it. Okay, the data doesn't matter for me, the concept matters. So from this case number 4, I think all the 4 cases it is very much clear to you how to calculate speed and velocity and what is the difference between speed and velocity. Speed is a scalar quantity and velocity is a vector quantity. Okay, so these are the different cases, and this total distance upon total time or total displacement or total time, when we say, we generally name it as average speed and average velocity when we are taking total distance and total time. Specifically, we must write here average speed and average velocity. This is total distance upon total time or total displacement upon total time, average speed, average velocity. But there is one more term related to this speed and velocity, and that is instantaneous velocity, which is very much important for class 11 students. For class 9 students this much is enough, but for class 11 students, if I talk about, there is one more term, instantaneous speed and instantaneous velocity. Now if we talk about what is instantaneous speed and instantaneous velocity, in this diagram if I take, in the same diagram in case number 1 what I have taken, in same diagram if I take here, suppose this is a straight line, point A to point B, okay, and here I am writing x1, it is x2, t1 is suppose 0 and t2 is suppose 10 seconds if I am talking about. If I ask you what will be the speed and velocity of a body at 2.1 सेकेंड, मतलब जब टाइम 2.1 सेकेंड हुआ होगा तब स्पीड और वेलोसिटी क्या होगी बॉडी की. ओके, अगर इस टाइम को मैं और थोड़ा सा बढ़ा दूं, सपोज t2 is equals to 1 hour, and if I ask you what will be the velocity of the body on 5th minute, 5th मिनट में आई एम टॉकिंग अबाउट सिर्फ उस पर्टिकुलर 1 मिनट की बात कर रहा हूँ. कौन सी? 5th मिनट की या 10th मिनट की या 7th मिनट की या 21st मिनट की या 21st सेकेंड की या 5th सेकेंड की या 10th सेकेंड की. So what I am saying, I am asking about the velocity or speed at a particular instant, not total. जब बॉडी ने स्टार्ट किया होगा चलना तो 5th मिनट पे जब बॉडी पहुंची होगी तो उसकी स्पीड और वेलोसिटी क्या होगी. ठीक है, दैट पर्टिकुलर velocity or speed will be called as instantaneous speed or instantaneous velocity. Instantaneous speed and instantaneous velocity. Now what is the format to write instantaneous speed and instantaneous velocity? We have taken that the speed is equals to del x upon del t. Same is the formula for velocity also, del x upon del t. Just the meaning is different. Here x indicates distance, here x indicates displacement, whatever it will be for that particular case. So for instantaneous speed I will write limit del t tends to 0 del x upon del t, and for velocity again I write limit del t tends to 0 del x upon del t. Okay, just for the difference sake I am writing y instead of x. You may write x, you may write z also. वेलोसिटी के लिए मैंने y ले लिया डिस्प्लेसमेंट. x जो है वो डिस्टेंस को इंडिकेट कर रहा है, y जो है वो वेलोसिटी को इंडिकेट कर रहा है. नाउ व्हाट इज द राइट मीनिंग ऑफ राइटिंग दिस lt? lt that means limit. When I am writing limit del t tends to 0, it means time is dead, very small, very small. When I am talking about this 1 hour और मैं आपसे पूछी कि what will be the velocity on 10th second or 15th second or 20th second, I am talking about that particular 1 second. I am talking about that particular 1 second. That means 1 hour के कंपैरिजन में अगर 1 सेकेंड की मैं बात करूँ तो बहुत ज़्यादा स्मॉल है, जीरो नहीं है, स्मॉल है. So this del t indicates that del t is very small. And as soon as I write limit del t tends to 0 in both the expression, I will be able to write it dx upon dt, and here I will write dy upon dt. आ गया differentiation यहाँ पे. ठीक है, I have launched one video on calculus also, calculus of x to the power n, differentiation and integration. This is the significance of differentiation and integration. We have started with calculus part here. Okay, so what is instantaneous speed or instantaneous velocity? The speed or velocity of a body at a particular instant is called instantaneous speed or instantaneous velocity. Okay, so this is all about today's class. We had a discussion on average speed and average velocity. We had a discussion on instantaneous speed and instantaneous velocity. Average means total, instantaneous means at a particular instant. Okay, see you in the next class. In the next class we'll have a discussion on acceleration, and we'll have a wonderful demonstration on acceleration relating it with force. Okay, thank you so much. See you in the next class.